Hello students, in the last video lecture we talked about the canonical form of the second order partial differential equation. So let me recall the steps again. First of all, you write down the PDE into the standard form, that will be RR plus SF plus TT plus function of x, y, z, p, q equal to 0. Okay, that means ये second order partial derivative है, the remaining जो होगा you have to write down as a function. Okay, so जो इससे प्रीवियस लेक्चर में हमने डिस्कस किया था, पहले उसे स्टैंडर्ड फॉर्म में कन्वर्ट करो, उसके बाद आपको वैल्यू निकालनी है एस स्क्वायर माइनस 4RT की. ओके, इससे कंपेयर करके RST की वैल्यू निकालो और देन यू फाइंड आउट एस स्क्वायर माइनस 4RT. इफ इट इज पॉजिटिव देन इट विल बी हाइपरबोलिक, इफ इट इज 0 देन इट विल बी पैराबोलिक, इफ इट इज लेस देन 0 दिस वैल्यू देन इट विल बी elliptic. Okay, after that you have to form some quadratic equation. So you have to form the quadratic equation by using this coefficient capital R, capital S, capital T, इनका यूज करके. So what you have to form? You have to form R lambda square plus S lambda plus T is equal to 0. This quadratic equation you have to form. So you will get, if this is a quadratic equation, you will get some two roots. Okay, say lambda 1 and lambda 2. So these two roots may be real and different, and that may be real and equal, and this may be complex also. Okay, now for these roots you have to form two differential equations. First differential equation dy by dx plus lambda 1 equal to 0, second will be dy by dx plus lambda 2 equal to 0. Then you have to solve it. That means you have to take the integral of that equations. When you find out this integral of these equations, you will get some function of xy. Okay, say f1 of xy, and इसका solution some function of xy, say f2 of xy. So f1 of xy equal to some constant, f2 of xy equal to constant. I call this function as some u. Okay, I call this is as some v. So I call this function u and v. So I call it as u and v. Okay, so what you have to do now, if you got both the values u and v, but sometimes it may be happen you are getting both the lambda 1 and lambda 2, both are the equal roots. अगर वहाँ से ऊपर आपके इक्वल रूट्स आते हैं, देन व्हाट यू हैव टू डू, यू विल गेट ओनली द वन फंक्शन, फंक्शन ऑफ एक्स एक ही मिलेगा आपको. यू से दैट फंक्शन इज यू. ओके, सो इफ यू आर गेटिंग यू, वी नीड वी आल्सो, बट हाउ टू फाइंड आउट दिस वी? How to find out this v? This v you have to form by yourself. And how to form this? In such a way, you have to form in such a way such that Jacobian is non-zero. Jacobian आपका क्या है? Jacobian of uv with respect to xy. तो वो Jacobian हमारा क्या है? That you know that determinant of partial derivative of u with respect to x, partial derivative of u with respect to y. In the second row, partial derivative of v with respect to x and v with respect to y. If this is non-zero, if this partial differentiation is non-zero, then this u and v will be independent. This independent solution you have to find out. Okay, so when you got u and v, so in the form of u and v, you have to find out the value of p, q, r, s, t. Okay, पहले आपका z था function of x, y. Now the z becomes will be the function of u v. Okay, then you have to find out the value of p, q, r, s, t in terms of u and v. When you get the value of p, q, r, s, t, so place that values in the first equation. जो अभी आपने जो ऊपर इक्वेशन निकाली है, जो ये इक्वेशन होगी आपकी, यहाँ पर p, q, r, s, t की वैल्यू प्लेस कर दीजिए. देन you will get the corresponding canonical form. Right? This is there. In some case, मान लीजिए if lambda 1 and lambda 2 जो आपके रूट्स थे ऊपर, वो अगर आपके कॉम्प्लेक्स आते हैं, कॉम्प्लेक्स रूट, so that means one root will be alpha plus iota beta, because complex roots always in conjugate pairs. Alpha plus iota beta, second will be alpha minus iota beta. Say this is u, this is v. So what you have to do, then आपके दो नए वेरिएबल और आ गए अल्फा और बीटा. देन हाउ टू डू, व्हाट टू डू, यू हैव टू फंक्शन की वैल्यू अब आपको u x और y की जगह u और v में कन्वर्ट करते थे, लेकिन अब u और v की जगह हमें अल्फा और बीटा में कन्वर्ट करना पड़ेगा. व्हाट आर द फंक्शन? दैट मीन्स नॉट द फंक्शन, द पार्शियल डेरिवेटिव्स p, q, r, s, t. Okay, all these value you have to find out in terms of alpha and beta. Okay, so whatever the equations you got after placing these values, that will be the canonical form. Okay, so canonical form for the hyperbolic equations, that means for the hyperbolic equation canonical form आपकी इस टाइप की होगी. For the parabolic canonical form will be of this type, and for the elliptic canonical form will be of this type. You can check that in the elliptic you are getting the equations in alpha and beta, and in the another you are getting the equations in u and v. Okay, so you can check that. it will be of this type when you solve it. So the best example we have already discussed in the last class. The similar examples are over here. Let me talk about this one. Classify and reduce the equation into the canonical form. So you have to reduce it. So first of all, you write down in the standard form. So this is r and this is t. So you write down this is r minus x square t. Okay. When this is in the standard form, so compare it with this one. When you compare it with this one, so find the value of capital R, capital S, capital T. So these values are this one, 1, 0 and minus x square. So now you have to find the value of s square minus 4rt. So find the value of s square minus 4rt, place this value, we got that value is 4x square. For any real value of x, this x square will be positive, 4 is also positive, 4x square will be positive. Okay. So you will say that, okay, so that means if for any non-negative values, this will be positive. If this value is positive, so you will say that this equation, this partial differential equation is hyperbolic. Okay, because s square minus 4rt positive, so it will be hyperbolic. So first step is done, this equation is hyperbolic. So what is the next step? You have to form the quadratic equation. So quadratic equation you have to form by using the value of capital R S T. So you have to form r lambda square plus l s lambda plus t equal to 0. Place the value r1 and s of 0 and t is minus x square, right? Then okay, so you place this value, you got that lambda square minus x square equal to 0. Find the value of lambda. Lambda is plus minus x. So two roots are there, plus x and minus x. For corresponding to these roots, one equation will be dy by dx plus lambda 1 equal to 0 and dy by dx plus lambda 2 equal to 0. Okay. So by using this value, we got the transformation of step means, that means we got u and v. How to find u and v? By using these equations. So how to solve this one? You can solve it. This is our first order partial differential equation. Place the value of lambda 1 and lambda 2 over there. So when you take the integration, some function of xy say u, some another function of xy say this is v. Square integration say this is equal to some constant, this is square integration, this is equal to some constant. I say this is u and this is v. Okay, u and v. So we got the value of u and v. Obviously you can check that these are the independent one. Okay, you can find out the Jacobian also, this will be non-zero actually. Okay, now by using this u and v, that means now z becomes the function of uv. So by using this thing, you have to find out the value of small p, q, r, s, t. So main thing is that find the value of p. So what is p here? Small p you know that will be curl z by curl x. But z you know that z is a function of uv. If z is a function of uv, so what you will say that curl z by curl x. You can check. So z is a function of uv. So firstly, partial derivative of z with respect to u into partial derivative of u with respect to x plus partial derivative of z with respect to v into partial derivative of u with respect to v with respect to x. Okay, that means by using the chain rule you will write down. But हमें अभी ऊपर से वैल्यूज पता है आपकी u और v की वैल्यू यहाँ पर आप क्या रख सकते हैं, ये आपका u, दिस इज v. So curl u by curl x, what it will be? Curl u by curl x, y derivative will be 0 and it will be 2x by 2, that means x. And here curl v by curl x, what it will be? That will be 0 minus 2x by 2, that means minus x. Okay. So when you place this value, it's plus x and this value is minus x. So remaining thing will be as it is, curl z by curl u into x, curl z by curl v minus x, right? So you can say that when you write down, that will be x into curl z by curl u minus x into curl z by curl v. Or in the another form also, you can say that what is this one? P is curl z by curl x actually. Okay. So when you take out the common, that means you write down curl by curl x of z. Okay, and this is curl by, sorry, now you can say that will be x curl by curl u minus x into curl by curl v of z. Okay. So what does it mean? That means this is the operator on z and this is also the operator on z. So this operator curl by curl x will be equal to actually this one, x into curl by curl u minus x into curl by curl v. Okay. So similarly now we find out the value for the q. when you find the value for the q, that will be curl z by curl y, but z is a function of uv. If z is a function of uv, so firstly partial derivative of z with respect to u into partial derivative of u with respect to y plus z with respect to v into v with respect to y. So you take this partial derivatives. So now you view the value of u and v, take their partial derivative with respect to y. So this is the place the value of u and v, take their partial derivative. That derivative with respect to y will be 1, that derivative with respect to y will be 1. Okay. So what it will be? That means curl z by curl u plus curl z by curl u. Okay. But what is q? q is here curl z by curl y. Okay. और इसी को हम रीराइट करके ले सकते हैं, when you take the z there, that will be operator actually curl by curl u, curl by curl v of z. Okay. So that means, sorry, this is curl z by curl y. So you can check that this is curl by curl y is the operator on z, curl by curl u plus curl by curl y is the operator on z. So that means curl by curl y is equal to this thing. So I write on this operator. Similarly, find out the value for r also. But what is r? R is curl square z by curl x square. This thing can be rewrite as, इसी को हम कैसे लिख सकते हैं? कर्ल by कर्ल x of कर्ल z by कर्ल x. Okay. But we got the value of कर्ल z by कर्ल x. कर्ल z by कर्ल x की वैल्यू आपको यहाँ से मिल गई है. So this is कर्ल z by कर्ल x actually. That means p. This is कर्ल z by कर्ल x. So you place this value over there. So when you place the value, you will get कर्ल by कर्ल x is as it is and its value is there. Okay. So when you write down this value, so partial derivative you have to take of this function, but there is a product of the function. First function is x and the second one is this one, this bracket. So you apply that partial derivative, I mean product rule. First function as it is, x as it is, partial derivative of that bracket, plus second as it is, partial derivative of first, that will be 1, right? So now you take the partial derivatives, you will get x into कर्ल z by कर्ल u, कर्ल by कर्ल x of कर्ल z by कर्ल u minus x into कर्ल by कर्ल x of कर्ल z by कर्ल v. Okay. And plus the remaining thing will be as it is. So we rewrite down the equations. Now you know that z is a function of uv. Z is function of uv. So this कर्ल z by कर्ल u is also कर्ल z by कर्ल u. That is also a function of uv. If this is a function of uv, so when you take the partial derivative with respect to x, again chain rule will be applied. So कर्ल z by कर्ल u का derivative first with respect to u into कर्ल u by कर्ल x plus कर्ल z by कर्ल u का derivative with respect to v into कर्ल v by कर्ल x. So that will be its value. Okay. Similarly, कर्ल by कर्ल x partial derivative with respect to x find out करना है कर्ल z by कर्ल v का. तो यहाँ पर कर्ल z by कर्ल v क्या है? फंक्शन है uv का. तो फिर वही पहले कर्ल z by कर्ल v का डेरिवेटिव विद रिस्पेक्ट टू u इंटू पार्शियल डेरिवेटिव ऑफ u विद रिस्पेक्ट टू x प्लस पार्शियल डेरिवेटिव ऑफ कर्ल z by कर्ल v विद रिस्पेक्ट टू v इंटू कर्ल v by कर्ल x. Okay, that will be this term. So we write down this term and the remaining term will be as it is. Right. So when you rewrite it, it can be written like this. You can check that. Just to place this value, you know the value for the u and v. So u और v की value place कीजिए, find out their derivatives. So कर्ल u by कर्ल x you have to find out. Just place the value of u and v. Okay. So when you find out with respect to x, that will be x only, and that will be with respect to x, that will be minus x. When you do with respect to x, that will be x, and with respect to x of this thing, that will be minus x. Right. So rewrite down the equations. That will be, what will be the equation? Thus you multiply this thing. This is x actually. So when x and x, that becomes x square into कर्ल square z by कर्ल u square. Okay. So that will be x square of this. X square I taken out common. So कर्ल square z by कर्ल u square. Now when you check this thing, it will be minus of x into कर्ल square z by कर्ल u कर्ल v. एंड एक x ये वाला मल्टीप्लाई होगा तो माइनस ऑफ एक्स स्क्वायर इंटू कर्ल स्क्वायर जेड बाई कर्ल यू कर्ल वी, एंड हियर x इंटू माइनस एक्स, तो एक्स स्क्वायर into cos square z by cos u cos v. So this is a plus sign, this is a minus sign, that will be cancel out. Okay, and here also minus x is there and minus x is there. So minus x into minus x, that becomes plus x square into cos square z by cos v square. So plus x square is already common, so cos square z by cos v square. Okay, so this is not of negative sign actually. This is of that minus x square and okay, sorry, this is of 2x actually. Partial derivative will be 2x by 2, that will be x and that is minus x. So minus x square and minus x square. Okay, so minus 2x square actually. So minus x square is common, that's why minus of 2 into cos square z by cos u cos v. Okay, and the term remaining as it is. So when you do it solve, so you will get the things actually. So the remaining term we will write down as it is. Now we find out the value for the t. So find the value for t. What is t? T is cos square z by cos y square. But it will be cos y into cos z by cos y. So you place the value for cos y. Cos y is cos y cos u plus cos y cos v, and cos z by cos y is cos z by cos u plus cos z by cos v. We place these values. Okay, you can check that in the above the values for the cos z by cos y and cos y cos y. You can check. This is the value of cos y, and q means cos z by cos y. Okay, you got this value. So you both the value you have to place over there to find the value for t. So t की वैल्यू के लिए हम इसे यहाँ पे प्लेस कर देते हैं. So how to do? Firstly, इस ब्रैकेट का पार्शियल डेरिवेटिव विद रिस्पेक्ट टू u प्लस इस ब्रैकेट का पार्शियल डेरिवेटिव विद रिस्पेक्ट टू v यू विल टेक. ओके, सो इसे सोल्व कर देखिए. पहले जब हम u के रिस्पेक्ट में इसे पार्शियल डेरिवेटिव करेंगे तो क्या होगा? cos स्क्वायर z बाई cos u स्क्वायर. सो दैट इज देयर. जब इसका सेकंड का डेरिवेटिव विद रिस्पेक्ट टू u करेंगे cos स्क्वायर z बाई cos u cos v. ओके, एक टर्म आ गई हमारे पास. फिर जब इस सेकंड टर्म का विद रिस्पेक्ट टू कल बाई कल वी, इस फर्स्ट टर्म का अगर मैं करता हूँ विद रिस्पेक्ट टू कल बाई कल वी, सो इट विल बी कल स्क्वायर जेड बाई कल यू कल वी. और एक टर्म मेरे पास पहले है कल स्क्वायर जेड बाई कल यू कल वी, सो दैट मीन्स दैट विल बी टू टर्म्स. ओके, एंड व्हेन यू टेक द डेरिवेटिव ऑफ सेकंड टर्म विद रिस्पेक्ट टू कल बाई कल वी, so it will be cos square z by cos v square. This will be as it is. So we got the value for p, q, r, s, t in terms of u and v. So what you have to do now? Just you place this value in the equation number 1. So when you place this equation in the equation number 1, you get this minus this is equal to 0. Okay. So after solving these equations, you will get minus 4x square plus this equal to 0. So you keep it left hand side cos square z by cos u cos v, and right hand side send them to right hand side and divided by 4x square. Okay, so 1 by 4x square will be equal to this thing. So actually this will be your canonical form. But firstly you have to place this value x square. What was that? X square. X square की वैल्यू हम u और v में फाइंड आउट करके रख सकते हैं. Okay, so how to find out this value? You know that u was this one and v was this one. So when you subtract each other, जब इसे सब्ट्रैक्ट करेंगे तो लेफ्ट साइड में तो बन जाएगा आपका u माइनस वी. जब राइट साइड में सब्ट्रैक्ट करोगे y विल बी कैंसिल आउट. x स्क्वायर बाई 2 माइनस x स्क्वायर बाई 2 विल बी 2x स्क्वायर बाई 2, दैट विल बी x स्क्वायर. तो x की वैल्यू क्या होगी? u माइनस वी. प्लेस दिस वैल्यू. सो जो u और v में सोल्यूशन है दैट इज एक्चुअली द कैनोनिकल फॉर्म. ओके, सो दिस थिंग यू हैव टू डू. Okay, now let me talk about the second example. That means, and this one you have to find the canonical form of this one, and its general solution you have to find out. So canonical form, you already understand that how to convert it into the canonical form. First of all, write down in the standard form is this is the value of r, this is the value of t, so you write down this is the value of q, so I write down this thing. Okay, when you write down in the standard form, so compare it with this one. So when you compare it, you will get the value for the capital R S T. So when you get the value of capital R S T, so you find the firstly find the value for s square minus 4rt. Okay, so it is already you have to find out this value in that form. Okay, so canonical form you have to convert it. So what you have to do? Just make the quadratic equation r lambda square plus s lambda plus t equal to 0 by using this value r s t. Okay, when we use this value we get this thing, n minus 1 square plus lambda square minus y raised to power 2n is equal to 0. So you have to find the values for the lambda, so that will be lambda square will be equal to y raised to power 2n divided by n minus 1 whole square. So taking root both sides, what you will get, lambda will be plus minus of that will be y raised to power n divided by n minus 1. Okay, so you got the two values of lambda. One is positive of positive sign y raised to power n by n minus 1, and another one of negative sign of y raised to power n by n minus 1, right? So we say this is lambda 1 and lambda 2. When you got the values, two values for the lambda, so write down the differential equations. dy by dx plus lambda 1 equal to 0, dy by dx plus lambda 2 equal to 0. Place the value for lambda 1 and lambda 2 over here. Okay, so that will be the differential equations. Now by using the separation of variable, you solve it. When you do the separation of the variable, you will get the solution of these equations, and you get the solution will be x minus, just you have to take the integration, you can check that. When you do the integration, you will get this thing. This is equal to constant, and x plus y raised to power minus n plus 1 will be equal to some constant. I call this is u and say this is v. So I take this is u and v. Okay, so what you have to do it now, just you have to take next step, find the value of p, q, r, s, t in the form of u and v. Now z becomes a function of u, v. Okay, now you have to write all these values in terms of u and v. So we just use the value of u and v as it is, these values, इनका यूज करके आपने पार्शियल डेरिवेटिव फाइंड आउट करने हैं. देन हाउ टू डू इट, p विल बी इक्वल टू कर्ल z बाई कर्ल x, बट z फंक्शन है किसका, u v का. सो यू से दैट फर्स्टली z का पार्शियल डेरिवेटिव u के रिस्पेक्ट में होगा, देन u का x के रिस्पेक्ट में, प्लस z का डेरिवेटिव विद रिस्पेक्ट टू v होगा, प्लस v का इनटू v का विद रिस्पेक्ट टू x, राइट. सो यहाँ पर मुझे पार्शियल डेरिवेटिव चाहिए ऑफ u विद रिस्पेक्ट टू x एंड ऑफ v विद रिस्पेक्ट टू x. तो u और v आपके पास ये रही वैल्यूज जो अभी आपने ऊपर लिखी है, इनका पार्शियल डेरिवेटिव निकाल दीजिए, देन यू विल गेट दिस वन. ओके, बट व्हाट इज p? p इज कर्ल z बाई कर्ल x. ओके, सो ये ऑपरेटर यहाँ पे z के ऊपर क्या लग रहा है, कर्ल बाई कर्ल x, और राइट हैंड साइड में ऑपरेटर क्या लग रहा है, ये ब्रैकेट. सो दैट मीन्स दिस कर्ल बाई कर्ल x इज इक्वल टू दिस ब्रैकेट, राइट. Similarly, you find the value for the q. When you find the value for the q, similarly you again apply the chain rule and find out the partial derivative of u and v with respect to y. So you do the derivatives and find out these values. So you will get this thing. Okay. So n minus 1 into y raised to power minus n is common actually. So what you will get, it will be कर्ल z by कर्ल u minus कर्ल z by कर्ल v. So this is the value for q, right. Over here also if you find out, this is कर्ल z by कर्ल y. So what is the value for कर्ल by कर्ल y? कर्ल y, just you take outside, this z is common outside. When you take z common outside, so value of कर्ल by कर्ल y is n minus 1 y raised to power minus 1 n कर्ल by कर्ल u minus कर्ल by कर्ल v. Okay. Now find the value for r. R is कर्ल square z by कर्ल x square. This will be कर्ल by कर्ल x into कर्ल z by कर्ल x. But you know the value for the कर्ल by कर्ल x and कर्ल z by कर्ल x. You place it over here. So when you do, firstly कर्ल by कर्ल u of this bracket plus कर्ल by कर्ल v of this bracket. So this value you got. Okay. Similarly for the t, when you use कर्ल square z by कर्ल y square, it will be कर्ल by कर्ल y of कर्ल z by कर्ल y. Okay. कर्ल by कर्ल y of this is कर्ल z by कर्ल y actually. So when you do it, so this n minus 1 is constant. So there are the two functions, y raised to power minus n into this bracket. So again you apply that chain rule. So how to do it? Firstly, second as it is, this is as it is here, and you take the partial derivative of y raised to power minus n. This will be minus n into minus y raised to power minus n minus 1. Okay, you get this thing. Plus this term is as it is. So this term is as it is, partial derivative of this remaining one. So remaining one you take. Okay. So one thing you have to understand over here. What is this? So this will be as it is, term will be as it is, this will be there. You have to find the partial derivative of this term. This is the कर्ल z by कर्ल u minus कर्ल z by कर्ल v. But in this term, u and v is included here. This is the function of u and v. Okay, u and v. बट हमें पार्शियल डेरिवेटिव फाइंड आउट करना है y के रिस्पेक्ट में. सो पहले इस टर्म का डेरिवेटिव विद रिस्पेक्ट टू u होगा, फिर u का विद रिस्पेक्ट टू y. तो देखो इस टर्म का डेरिवेटिव विद रिस्पेक्ट टू u है, फिर u का विद रिस्पेक्ट टू y, प्लस इस टर्म का पार्शियल डेरिवेटिव विद रिस्पेक्ट टू v होगा, फिर v का विद रिस्पेक्ट टू y. इस पास का टर्म विद रिस्पेक्ट टू v, देन v विद रिस्पेक्ट टू y. So partial derivative you can find out by your own easily. So you just find these values, that as it is partial derivative of this u and v. इसका partial derivative find out कीजिए. When you solve it after placing this value, first term as it is, partial derivative is there. When you take out this term is common here, you will left with this one, this and back to this one. Okay, you can easily understand. Okay, simplify just you have to do. So this PQRST you have to place this value into the first equation. When you place back this value into the first equation, you will get this one. Right. Now you have to collect the terms. So firstly we collect the terms of curl square z by curl u square. Okay. So when you collect these terms, you can check curl square z by curl u square. यहाँ पर इसका कोफिशिएंट है n-1 स्क्वायर. सो आई जस्ट टेक दैट कर्ल स्क्वायर z by कर्ल u स्क्वायर. फर्स्ट टर्म का कोफिशिएंट लिख दिया पहले n-1 होल स्क्वायर. देन और कहाँ पर आपका कर्ल स्क्वायर z by कर्ल u स्क्वायर हियर. ओके, ये टर्म आपकी किससे मल्टीप्लाई होगी y⁻2n से. सो माइनस ऑफ y⁻2n को इससे मल्टीप्लाई करेंगे तो y⁻2n एंड y⁻2n दैट बिकम्स 1. तो माइनस ऑफ n-1 स्क्वायर. ओके ओके, इन्होंने पूरा कंप्लीट लिखा है दिस वन. राइट. प्लस अब कोफिशिएंट हमें इसके कलेक्ट करने हैं कर्ल स्क्वायर z by कर्ल u कर्ल v के. जब इसके कोफिशिएंट कलेक्ट करोगे हियर इट विल बी 2 इंटू n-1 होल स्क्वायर. इट विल बी 2 इंटू n-1 होल स्क्वायर प्लस यहाँ से जब टर्म कलेक्ट करोगे इट विल बी 2 इंटू y⁻n, 2 इंटू y⁻n एंड n-1, 2 इंटू y⁻2n, right, into n-1 whole square into y⁻2n, right. So this terms we got. Now plus curl square z by curl v square when you count. So what it will be? It will be n plus n-1 whole square. So to write down n-1 whole square and remaining term will be, जब इसके साथ हम लेंगे that it will be y⁻2n into y⁻2n n-1 whole square, right. So these terms we got. बाकी जो बची हुई टर्म्स है जस्ट यू राइट डाउन ओवर हियर. ओके, जहाँ पे हमारा कर्ल z by कर्ल u माइनस कर्ल z by कर्ल v कॉमन है तो वो कॉमन लेके आप लिख सकते हो. दैट विल बी द रिमेनिंग टर्म्स. ओके, सो वन थिंग यू ऑब्जर्व हियर, y⁻2n and y⁻2n ये becomes 1. Okay, n-1 whole square minus n-1 whole square, so that terms becomes 0, right. Here also y⁻2n y⁻2n that becomes 1, n-1 whole square n-1 whole square that becomes 0. These terms will be 0 here. Here also y⁻n into n-1 n into n-1 y⁻2n y⁻n plus 1, so that becomes y⁻n-1 and here also y⁻n-1. This is a positive sign, this is a negative sign, so this term is also eliminated. For what is left here, curl square z by curl u square and this y⁻2n y⁻2n becomes 1. So that means 2n-1 whole square plus 2n-1 whole square, that will be 4n-1 whole square. Okay, that is equal to 0. So this is the constant term, so send to right hand side curl square z by curl u curl v equal to 0. So this is actually the canonical form of the given example. Now you have to solve it, find out the solution of this one. So how to find out the solution? Just you have to take the integration with respect to u and v. So when you take the integration with respect to v, so when you take the integration with respect to v, it will be curl z by curl u and right hand side equal to constant. But हमारे यहाँ पर constant क्या है, जब v के रिस्पेक्ट में इंटीग्रेशन कर रहे हो u constant है, so that means right hand side will be the constant will be u, so that will be some function of u. Okay, again you have to take the integration with respect to u. When you take the integration with respect to u, so that left hand side will be z, it will be integration of gu du plus some constant हमारा अब क्या है v, so यहाँ पर लिख सकते हो f of v, right, whatever the thing, so you will get this thing u du plus function psi of v. Okay, and अब जब इसका इंटीग्रेशन करोगे दिस विल बी सम फंक्शन ऑफ u, आई कॉल दिस इज phi of u and this is psi of v. So phi of u plus psi of v is equal to z. This is your solution actually, but u और v की वैल्यू आपको ऑलरेडी पता है, so just place the value of u and v. This will be the value for u, this is the value for v. So this is the general solution of the given second order partial differential equation. So सो इसमें हमने क्या किया कि हमारे पास जो भी सेकंड ऑर्डर पार्शियल डिफरेंशियल इक्वेशन थी उसे हमने कैनोनिकल फॉर्म में कन्वर्ट किया। कैनोनिकल फॉर्म में कन्वर्ट करने के बाद वो सिंपल सेकंड ऑर्डर पार्शियल डिफरेंशियल इक्वेशन बन गई। फिर उसका हमने आसानी से सोल्यूशन फाइंड आउट किया। ओके, इन दिस वे यू हैव टू सॉल्व दिस क्वेश्चंस। द नेक्स्ट वी विल डिस्कस इन द नेक्स्ट क्लास। थैंक यू स्टूडेंट्स।